Hello everyone, welcome back to this online class. Today we are going to look at numerical integration, and in particular we are going to look at the trapezoidal rule and Simpson's rules. So we have this question. We are asked to estimate the integral from 1 to 3 of x squared times exponential negative 2x dx, correct to 5 decimal places, using part A, composite trapezoidal rule with 7 ordinates. Part B, Simpson's a third rule with 7 ordinates. Part C, Simpson's 3/8 rule with 7 ordinates. Obtain a bound for the truncation error in each case. Also find the absolute error incurred in each approximation. So, if you look at the given integral, let me take you back. If you look at our integral, our A is 1, our B is 3, our f of x is x squared exponential negative 2x. So we can just write a summary here that A is equals to 1, B is equals to 3, f of x is equals to x squared exponential negative 2x. And we are told to use 5 decimal places accuracy. Of course, that will account for that later. What is important here is that in each case, we need to use 7 ordinates. I told you previously that the number of ordinates is 1 more than the number of the subintervals. So 7 ordinates simply means that if I need to find n, it will be 7 minus 1. N there means the subdivisions, number of subdivisions, or the number of strips. So you can say here that n is equals to the number of ordinates you less 1. So because we are using 7 ordinates, that would be 7 minus 1, and so our subdivisions are 6. So once you have n, you can now be able to calculate h. Remember, h is equals to b minus a over n. And so our b is 3, a is 1, our n is 6. That is 2 over 6, which if you simplify, you get 1 over 3. And we said h here means the step size, or the interval between those strips, those ordinates. Now, having found n and h, let's now come up with a table of x versus f of x. So you'll have x, and then f of x. Remember, we are starting from the value 1. We want to go all the way up to 3 in step size of 1 over 3. So what we'll have here is when x is 1, starting from 1, what will be our f of x? Press in your calculator. You're going to get 0.135335. 0.135335. Continue. Add the steps as of 1 over 3 to 1. 1 plus 1 over 3, we get 4 over 3. F of x, remember f of x is x squared times exponential negative 2x. So replace 4 over 3 into x squared times exponential negative 2x. What are we going to get? That will be 0.123526. I'm rounding up to correct to 6 dp. The next is 5 over 3. We are just adding 1 over 3. That's the step size. This will give you 0.099094. Go to 6 over 3, which is 2. That should give us 0.073263. 3263. I go to 7 over 3. Our f of x is 0.051197. Go to 8 over 3. That should give us 0.034332. And finally, we go to 9 over 3, which is 4. Of course, 9 over 3 is 3, not 4. So we go to 9 over 3, which is 3. And so that is 0.022309. So that's the table of x versus f of x. Now, once we have this table, the next thing is now to show you how to use the table. Once you have the table, this is what you're going to do. You write here f0, f1, f2, f3, f4, f5, f6. So we can now answer the question part A all the way up to part C. Let's start with part A using trapezoidal rule. Part A, here we want to use composite trapezoidal rule. So you can write using composite trapezoidal rule. Remember the rule that if you want to integrate from 1 to 3 of x squared exponential negative 2x dx, this is approximately equal to h over 2 into, it's always equals to the sum of end ordinates when I talk of the end ordinates are f0 and f6. Those are the end ordinates. Then plus twice sum of middle ordinates. That is the trapezoidal rule in words. So what does it mean? This is the same as writing h over 2. End ordinates, we have f0, f6 will be somewhere here, plus f6. Then the middle ordinates are from f1 to f5, so those ones we multiply by 2. So plus 2 times f1 plus f2 plus f3 plus f4 plus f5. So you have their values, you don't need to write again. Just read the values from the table and substitute, press everything in your calculator. You need to get, remember h is 1 over 3, don't forget, we found it here. This is our h. So that would be 1 over 3 divided by 2, which is 1 over 6. And this function of values, you have them from the table. So if you need f0, you just replace with the value here. If I need f1, you know the value. So just press with the values in the table. This is what you need to get. You need to get 0.15341. Remember, we are rounding off correct to 5 decimal places. The answer you have found in your calculator, you need to round it off to 3 dp. Not 3, but 5 dp. That is the first one. Another one is Simpson's third rule. That is part B. So I'll write it here. Part B, you write using Simpson's third rule. Simpson's 1/3 rule. So what does it state? That the integral from 1 to 3 of exponential x, not exponential, but x squared times exponential negative 2x dx. This is approximately equal to h over 3. That's why we call it 1/3 rule. Times, I want to state it in words, just like the trapezoidal one. It is also the same as it's the sum of end ordinates end ordinates are f0 and f6, then plus twice sum of middle ordinates whose subscripts are divisible by 2. Then lastly, we have 4 times the sum of middle ordinates whose subscripts are not divisible by 2. That is Simpson's 1/3 rule in words. So there's a bracket here. Now, why do we insist that there are those that are divisible by 2, others not divisible by 2? Usually, what you need to take note of when using Simpson's 1/3 rule is that the restriction is that n must be a number divisible by 2. By 2. That is the restriction in using Simpson's 1/3 rule. Look at our n. Our n was 6, and so 6 is divisible by 2. If you found maybe your n to be a number that is not divisible by 2, then you cannot use Simpson's 1/3 rule. Take note of that. If your n is, let's say, 5, or even 9, or even 7, those are numbers which are not divisible by 2, and so this formula cannot work in such a case. For the trapezoidal rule, there's no restriction. The restriction is in the Simpson's 1/3 rule, where n should be an even number. So now, let's in terms of the function of values, how will we write this formula? It is h over 3. Our end ordinates are f0. Then there will be f6 somewhere here, plus f6. Then we have to check the subscripts which are divisible by 2. Apart from the end ordinates, because those ones we have used already, I've used this and this. So we don't consider them. We remain with from f1 to f5. Between f1 and f5, which ones are divisible by 2? I can see f2, 2 is divisible by 2, f4, because 4 is divisible by 2. So it will be f2 plus f4. So we'll have here f2 plus f4. Then we have 4. Now, still on those middle ordinates, but whose subscripts are not divisible by 2. It is f1, f3, and f5 for the remaining ordinates. So I'll write them down here. f1, f3, and f5. So right here, f1 plus f3 plus f5. Then you can see this f6 here. Now press this in your calculator. H is 1 over 3, remember? So that would be 1 over 3 divided by 3, that is 1 over 9. And this function of values, f0 all the way up to f6, you can refer to the values in the table. When you press in your calculator, you need to get your answer as 0.153 0.15363. Remember, we are rounding off to 5 decimal places. And finally, part C, now using Simpson's 3/8 rule. So right here, part C, using Simpson's 3/8 rule. Let me state the formula in words. We are integrating from 1 to 3 of x squared exponential negative 2x dx. This is approximately equal to 3h over 8. That's why we call it Simpson's 3/8 rule, because this time h you are multiplying by 3 over 8. So we, as usual, we add the end ordinates. So right here the sum of end ordinates. In this case, it is f0 plus f6. Then plus twice the sum of middle ordinates whose subscripts are divisible by 3 plus 3 times the sum of middle ordinates whose subscripts that should be subscripts are not divisible by 3. So that is Simpson's 3/8 rule in words. Let me close this bracket. And the other closing bracket. Now, even here there's a restriction. You can write a note here that the restriction in using Simpson's 3/8 rule is that n must be a number divisible by 3. You need to check what is our n in our calculation. N is equals to 6. It is clear that 6 is divisible by 3. So we can be able to use this formula to approximate that integral. But what about if n was 5, n is 8, n is even 10? Those are numbers which are not divisible by 3. And so in such cases, you cannot use Simpson's 3/8 rule. Take note of that. So in terms of functional values, how do we write this formula? It is 3h over 8. End ordinates, that is f0 and f6 will be somewhere here. f6. Then plus 2. Now, between the end ordinates, now we remain with f1 to f5. Check those that are divisible by 3, the subscripts which are divisible by 3. Let me take you back. Between f1 and f5, I can only see it is f3, because 3 is divisible by 3. So we only have f3. So right there, 2 times f3. The rest are not divisible by 3. So it is only f3, 2 times f3, nothing else, then plus. Now 3 times, the remaining are f1, f2, f4, f5. That's the formula. If you press this in your calculator, h is 1 over 3. So we'll have 3 over 8 times 1 over 3, which is 1 over 8. Then the functional values from f0 all the way up to f6, you can refer to your table press everything in your calculator, you need to get 0.15358. Again, this is correct to 5 decimal places, 5 dp. Remember, these are approximate values. We don't know the exact value, which we are going to find. We also don't know the amount of error that we are going to incur. We can also find that. And also the bound, the range for the truncation error, which we are going to find. So first of all, let's look at how to find truncation error bound in using each of those approximations. So write a subtopic, you write here truncation error bound. Truncation error bound. So let's start with the part A. How do you find the error when you use trapezoidal rule? So you can write here part A using trapezoidal rule. So this is how you are going to find the error when you use trapezoidal rule. The formula is that the absolute error should be less or equal to b minus a over n over 12, times h squared times the maximum between a less or equal to x less or equal to b of the absolute value of the second derivative of that function f of x. That's how to find the absolute error. Of course, the bound for the absolute error. When you talk of the bound, it means the range. It ranges between what and what. That's what I mean by truncation error bound. Now, we know b from our given integral. We know a, we know h. What we don't know is this maximum value, which we can find. Is how to find it. So you're going to write that we have f of x given by x squared times exponential negative 2x. So that's x squared exponential negative 2. I want to get the first derivative, f prime of x. Use product rule. This will be your u. This will be your v. Remember product rule that to differentiate ddx, of u times v, of uv is the same as u prime v plus u v prime. That's the product rule of differentiation. It is used when you're differentiating a product of two functions of the same independent variable. So here, this will give us 2x exponential negative 2x plus now x squared times negative 2 exponential negative 2x. If I simplify this, I'm going to get 2 into x minus x squared exponential negative 2x. Let's get the second derivative, f double prime of x. Again, this is 2, still using product rule. That's 2 into 1 minus 2x exponential negative 2x plus x minus x squared times negative 2 exponential negative 2x. And this can as well be written as 2 into 1 minus 2x minus another 2x plus 2x squared exponential negative 2x, or 2 into 1 minus 4x plus 2x squared exponential negative. So that's our second derivative. Now let's see between a and b. This is just like maximizing a function between some interval, finding the absolute maximum of a given function. That's what it means. So our focus is on this second derivative. Let me bracket it. Our interval is from 1 to 3. So you can say that when x is equals to a, and in this case our a is 1, what will be this absolute value of the second derivative of x? That should give us, and let's see, when I put 1 here, I'm going to get 2 into 1 minus 4 plus 2. 10 times exponential negative 2. Press that in your calculator. What do we get? We are going to get 0.2706. Of course, in absolute, it was negative. Then when you take absolute value, you get 0.2706, 0.2706, 7057. That's what we are getting. What about when x is equals to b, which is equals to 3? What will be the second derivative, or the in absolute value at x is equals to 3? If you substitute 3 here, you are going to get 0.0347, 0.0347. So between those two values, which is the maximum value? The maximum is 0.2706, 7057. So you can indicate here that this is the maximum. This is the maximum. So it means where we have the whole of this value, instead of this, we are going to replace it by 0.2706, 7057. So you can say that therefore, the absolute error should be less or equal to 3 minus 1 over 12, 1 over 3 squared, that's h squared, times 0.2706, 7057. And this is the same as writing. Let's press that in our calculator. What do you get? You're going to get 5.01242. 5.01242. This is times 10 raised to negative 3. So it means that anything between negative 5.01242 and times 10 raised to negative 3, I mean, then positive 5.01242 times 10 raised to negative 3, that is the amount of error that you incur. It simply means that our error ranges between negative 5.01242 times 10 raised to negative 3. This should be less or equal to our error less or equal to positive 5.01242 times 10 raised to negative 3. So negative, positive, because error can be negative or positive, but it should be a value between those limits. That's what I mean by the truncation error bound when using trapezoidal rule. Now let's see how to find the error bound when using the Simpson's third rule, part B. And you will see when we get to the exact solution or the exact value, you will see the absolute error that you will get, and you will see that clearly it will be a value that falls within those ranges. So part B, write using Simpson's rule was a third rule. Using Simpson's third rule. So this is how you need to get the error bound in this case, that the absolute error should be a number less or equal to b minus a over 180 h raised to 4 times the maximum between a less or equal to x less or equal to b, maximum of the absolute of the fourth derivative of f of x, fourth derivative. Now, it means we need to go all the way up to the fourth derivative. So let's proceed with this differentiation. Find the third derivative, fourth derivative. So you write f double prime, f triple prime, I mean, of x. That should give us 2 into differentiate 1 minus 4x plus 2x squared. That will give us negative 4 plus 4x. Keeping exponential negative 2x constant, then plus, now keep 1 minus 4x plus 2x squared constant. Differentiate the exponential function, you get negative 2 exponential negative 2x. If I simplify this, I'm going to get 2 into negative 4 plus 4x minus 2 plus 8x minus 4x squared, exponential negative 2x, which will give me 2 into negative 6 plus 12x minus 4x squared, exponential negative 2x. I can see 2 is common, so this will be 4 into negative 3 plus 6x minus 2x squared, exponential negative 2x. Let's get the fourth derivative. Fourth derivative of that function, that is equals to 4 into 6 minus 4x exponential negative 2x. Then now plus negative 3 plus 6x minus 2x squared as a constant times negative 2 exponential negative 2x. If I simplify this, I'm going to get 4 into, that is 6 minus 4x plus 6 minus 12x plus 4x squared, exponential negative 2x. Still, this can give me 4 into 6, that is 12, minus 16x plus 4x squared times exponential negative 2x. I can see 4 is common. That can be factored out so that we get 16 outside. So this should now give us 16 times, we are factoring out 4, remember, so that here we'll have 3 minus 4x plus x squared, exponential negative 2x. So our focus is on the fourth derivative. We want to know the maximum value of this fourth derivative between the interval a and x is equals to a and x is equals to b. Anything between those limits. So let's see how to find it. We are going to say here that when x is equals to a, remember our a is 1, when x is equals to a, which is equals to 1, what do you think will be the absolute value of the fourth derivative of f of x? So you press, substitute x is equals to 1 in this fourth derivative here. If I put 1, I can see I'm going to get 0. You're getting 0, not bad. What about at the other end, when x is equals to b, which is equals to 3? What do you think will be the absolute value of the fourth order derivative of f of x? If I substitute 3 again into this fourth derivative, it is clear that I'm getting 0. So those are the values at the endpoint. Can we conclude that those are the maximum values? No. There might be another value in between a and b. How do you find that other value? What you do is you apply the technique of maximizing and minimizing a function, or simply what we call the turning points. We need to know between a and b, where will this function turn? So you need to take note that whenever you get 0 and 0, think of a turning point. It means there's a turning point between a and b. Let's see whether we can find the turning point. And once you know the turning point, you can be able to find the value of this fourth derivative at that turning point. So you can right now find the turning point. Find the turning point. Turning point of this fourth order derivative of the function, this one, between x is equals to a and x is equals to b. Remember, a is 1 and our b is 3. So this is how you're going to get the turning point. You're going to say that let g of x be equal to that fourth order derivative, that is f raised to 4 of x. And what was it? It is 16 times 3 minus 4x plus x squared exponential negative 2x. How do you find the turning point of any given function? Like in this case, g of x. So I have to differentiate that g and then equate the derivative to 0 and then solve for x. That's how to find the turning point of the function g of x. So let's find its derivative. So now g prime of x is equals to 16 times. Now differentiate u, keeping v constant. That will give us negative 4 plus 2x exponential negative 2x plus, now u is constant, that is 3 minus 4x plus x squared. Differentiate the exponential function, you get negative 2 exponential negative 2x. If I simplify, this is what I need to get. 16 into, I can see we'll have negative 4 plus 2x minus 6 plus 8x minus 2x squared. Exponential negative 2x. Or 16 times, that's negative 10. Then plus 10x minus 2x squared. Exponential negative 2x. This, I can see 2 is common. You can factor out 2 or even negative 2, whichever. Let me factor out 2 so that this is the same as 32 into negative 5 plus 5x minus x squared times exponential negative 2x. So now I need to equate it to 0. This is equals to 0 because g prime of x is equals to 0, and then solve for x. So you write g prime of x is equals to 0. That means 32 times negative 5 plus 5x minus x squared exponential negative 2x is equals to 0. So when you simply remember, the exponential cannot be 0, 32 cannot be 0. So it is negative 5 plus 5x minus x squared that can be 0. So from here, it simply means that, let me write it this side. This simply means that negative 5 plus 5x minus x squared is the one that is equals to 0. And so how do you find x? Of course, you can divide through by negative so that we rearrange it so that we have x squared minus 5x plus 5 should be able to give us 0. So how do we find x? Use quadratic formula. Negative of b, that's 5, plus or minus the square root of b squared. B squared will give us 25 minus 4 times a. A is 1, c is 5. 4 times 1 times 5, that is 20. Everything you divide by 2 times a, which is 2 times 1, which is 2. So this is 5 plus or minus root 5 over 2. Let's see. Our interval is 1 to 3. Remember the interval. X is a member of the interval 1 to 3. You need to know these values of x that you have found, which one falls within the interval. Let's see the positive one. 5 plus, we have 5 plus root 5, and the answer you divide by 2. We are going to get 3.61. That is not within the interval 1 to 3. What about if it is 5 minus? If I use minus, I'm going to get 1.38, which is clearly inside the given interval, which is 1 to 3. So you can say only x is equals to 5 minus root 5 over 2 lies within the interval 1 to 3. Only x is equals to 5 minus root 5 over 2 lies in the interval a less or equal to, instead of a, let me use 1 less or equal to x less or equal to 3. So that is the turning point. Now we need to know what is the value of the fourth derivative at this turning point. So you can now say at this point, let me bracket it, at this point, you need to get the absolute value of your fourth derivative, that is raised to 4 in bracket, of x. Look at our function. So what do we need to get? We replace it here, the one that I have ticked in red. So where there is x, we are going to put 5 minus root 5 over 2. And then you press that into in your calculator. What are you going to get? Let's see. You can press that. If I press in my calculator, I am going to get 0.6234, 0.6234, 0735. So now the question is, at the endpoints, the value was 0. And we have found a point between the endpoints where the value is a number greater than 0. So we need the maximum between this one, this other value, and finally what we have found down here. It is clear that this is the maximum value that you are looking for. So when I go back to my absolute error formula, where we have this maximum value, I'm going to replace it by 0.6234, 0735. So the value here is 0.6234, 0735. You know H, you know B, you know S. So let's replace those values now and see how to find the error. So you can say that therefore, our absolute error should now be a value less or equal to 3 minus 1 over 180 h raised to 4. That's 1 over 3 raised to 4 times the maximum value, which is 0.6234, 0735. Let's press this in our calculator. What do you get? So when you press in your calculator, this is what you get. It is 8.55, 8.55, 154. And this is times 10 raised to negative 5. That is 10 raised to negative 5. What does it mean? That when you use Simpson's third rule, then your error should range between negative 8.55154 times 10 raised to negative 5 and positive 8.55154 times 10 raised to negative 5. Let me write this down here. You can say, or negative 8.55154 times 10 raised to negative 5 should be less or equal to our error E, less or equal to positive 8.55154. This is times 10 raised to negative 5. So that's the error bound when you use Simpson's third rule. Now look at this interval. It's even this is very small interval to the power of negative 5, 10 to the power of negative 5. What about what we got in the trapezoidal rule? You realize that this interval is bigger than the one that we have found in Simpson's a third rule. So it means Simpson's a third rule is even much more accurate. It's more accurate than the trapezoidal rule. In fact, even from the error, you can just see. From the error, you can see which one is better than the other. And finally, let's see how to find the error bound when we use Simpson's 3/8 rule. So you can write part C using Simpson's 3/8 rule. How do you find the error in this case? So this is the formula that the absolute error should be a value less or equal to b minus a over 80. Now it is not 180 but 80 h raised to 4 times the maximum between a less or equal to x less or equal to b of the absolute value of the fourth order derivative of the function f of x. The same things we did in Simpson's third rule. The only difference that in this case it is 80, the other one was over 180. So just import the same values that we have used. I can see there was 0 when x is a, there was also 0 when x is b, and finally when x is 5 minus root 5 over 2, we got 0.62340.735, which is the maximum value. So we just import it. We don't need to do that again. So instead of this maximum value, let's import the value that we have found in the Simpson's 1/3 rule. It was 0.6234, then 0.735. So you can say this is equals to, let me write it here, 3 minus 1 over 80, 1 over 3, that's our h, raised to 4, times 0.62340735. So this one, when you press in your calculator, you need to get 1.924097, 1.924097. This is times 10 raised to negative 4. 10 raised to negative 4. Let me write that properly. Times 10 raised to negative 4. So what does it mean? It simply means that negative 1.924097 times 10 raised to negative 4 should be less or equal to our error E, less or equal to positive 1.924097 times 10 raised to negative 4. So our error, whether negative or positive, should range between that interval. So let me bracket this. So I have now shown you how to find the truncation error bound. Now, something that I need to mention between the value we have found in part C and part B. Look at part C. It is 10 raised to negative 4. And in part B, it was 10 raised to negative 5. So from here, you can just say that Simpson's 1/3 rule is more accurate than Simpson's 3/8 rule, just based on the error bound that we can see. The interval here is greater. This interval, let me take it, this one that interval is bigger than this other interval. And you can even see the power of 10. And finally, let me show you how to find the exact value of that integral. So you can write a subtopic here, exact value. Exact value. When you talk of exact value, what you need to do is to use the techniques of integration. We need to integrate, let me write it. We need to integrate from 1 to 3 of x squared times exponential negative 2x dx. So using the techniques of integration, which one do you think we need to use here? As long as you see a product of two functions of x and one is not the derivative of the other, then you need to use integration by parts. So this will be our u, and these others will form dv. So we are going to use integration by parts. Now you realize that our u is a polynomial. Whenever u is a polynomial, to make your work easier, use tabular integration. Tabular because u is a polynomial. So you can say since, let me write that properly. Since u is a polynomial, use tabular integration. This will make your work easy. Of course, I know integration by parts, the long process will work for you, but will take a lot of your time. Let's see how to simplify our work here. So in tabular integration, I only need to know u, a column that contains u, and another columns having dv over dx. So that here, our u is x squared, dv over dx, that is exponential negative 2x. So in the first column, you differentiate until you get to 0. So when you differentiate x squared, you get 2x. The other column you integrate. So the integral of exponential negative 2x is the exponential negative 2x divided by negative 2. Continue differentiating 2x, that will give us 2. Continue integrating this other side, that is exponential negative 2x divided by 4. Proceed until the derivative, the first column gives you 0. And that's where you need to stop. So when you differentiate 2, remember 2 is a constant, so that when you differentiate, you get 0. If I integrate exponential negative 2x over 4, that will give us exponential negative 2x over negative 8. Now, once you have found those ones, you now link them. This will be linked to this. This one, link it to this other function. And finally, this you link to this other function. And then you give them the signs. Here we have positive. Here we have negative, then followed by positive. In that order, they must alternate from positive, negative, in that order. And those arrows means you are multiplying. So it's the first arrow means that the sign is plus the product of x squared and exponential negative 2x over negative 2. You multiply and the sign is a plus. So therefore, let me have it done this side. Therefore, the integral from 1 to 3 of x squared exponential negative 2x dx is the same as, let's start with the first arrow. That first arrow means that the sign is a positive, then x squared times exponential negative 2x over -2. Second arrow, the sign is a minus. We have here 2x times the other one is exponential -2x over 4. The other arrow is a plus. Then we have 2 times exponential -2x over -8. That's what it means from 1 to 3. Let me simplify. When you work out that, I can see we'll have -1 over 2x squared minus 1 over 2x minus 1 over 4. This one should multiply exponential -2x. That was common. Then our limits are from 1 to 3. If I factor out -1 over 4, this is what I can get. -1 over 4 outside. Then inside, this is what we remain with. 2x squared plus 2x plus 1 exponential -2x from x is equals to 1 to 3. So we can press, this will give us -1 over 4. When I substitute the upper limit is 3. So that will give us 2 times 3 squared. Let me write it. 3 squared is 9. So that will give us 18 plus 6 plus 1 exponential -6. Then subtract. When I use 1, I'm going to get 2 plus 2 plus 1 exponential -2. When you press this in your calculator, your answer should be equal to, of course, remember we are going to round off to 5 dB, 0.153, 0.15368. So your solution should be that when you round up to 5 decimal places. So now we want to do a comparison. I'm going to write a table, or simply draw a table where we summarize what we got in the trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule, so that you see which one is more accurate. Of course, when we are comparing 3 things, we talk of the most accurate. When it is 2, we talk of more accurate. So in this case, we have 3 items to compare. We need the most accurate solution. So a summary. We have here a summary. We'll have a table. I'll have here the rule. A table of this manner. So we have how many rules? There are 3 rules. Number 1 is trapezoidal. Number 2 is Simpson's, the 3rd rule. One over 3. And the other one is Simpson's 3/8 rule. So those are the rules. Let me construct this table. So we need this kind of a table where we have the rules, then what we got as the approximate value, the truncation error bound, and the absolute error. Of course, we know the exact value. What we have found here is the exact value. So when you want to get the error, it is the exact minus the approximate. Then you get the absolute. So let's populate this table. So this is how our table should look like. Remember, when getting absolute error, it is this value, which is the exact value minus the approximate value. So like in the case of trapezoidal, you have 0.15368 minus 0.15341, the value you get here. There's a difference between the error bound and the exact error. So absolute error is this one, but the bound tells you the range. Clearly, you can see like 2.7 times 10 raised to negative 4. It is a value less than the given interval for the error bound. Similarly here, so it means that if you found the error to be outside this given error bound, it means what you have done is wrong. Again, you can also check here, it is less than this value that we wrote here. So which one do you think is the most accurate? Look at the error. I can see when you use Simpson's a third rule, this is the most accurate solution. So you can comment on this and say that Simpson's third rule is the most accurate. This is number 1, followed by 3/8 rule is number 2. Then the worst case scenario is when you use trapezoidal rule. There is a lot of error that is involved in the calculation. So that's how to go about such kind of problems. That is numerical integration when you use trapezoidal rule and Simpson's rules. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at more problems involving numerical integration. Bye-bye.